Uh, this is the Carnot cycle. Carnot cycle. Now you see, there are four processes. I will explain it here. There are four processes: 1 to 2, 2 to 3, 3 to 4, and 4 to 1. Okay. Now this 1 to 2 is the isothermal heat addition process. Q1 is the heat added in this process. This is the equation of the isothermal. Here temperature is constant. These temperatures, let us talk about T1. Okay. Then this is an adiabatic process 2 to 3. Adiabatic expansion. This is the equation for adiabatic process. Then 3 to 4. Again, this is an isothermal heat rejection, that is the Q2. This heat rejection to the atmosphere. Okay. This is the sink, to the sink, and this heat is added from the source. Now this point, from this point to this point, again compression, frictionless adiabatic compression. So these are all frictionless with all processes. So PV to the power gamma is equal to constant. This is again constant. This is the PV diagram of that Carnot cycle. Now Carnot made some assumption. Without this, it is not possible to derive the efficiency. 1. The assumptions are: first one, the piston moving in cylinder does not encounter any friction during motion. This is the one. Number 2, the walls of piston and cylinder are perfect insulators of heat, means heat should not go out from the system. Here, the walls, from the walls, the head of cylinder is so arranged that it acts as perfect conductor and also as a perfect insulator. That means it is interchangeable cylinder head. Okay. Now number 4, the heat transfer to and from source and sink does not change the temperature of source and sink. That means the source are thermal reservoir. Okay. Now I will go to the operation purposes directly. The This is the actual arrangement of the, this is the cylinder and this is the piston. Okay, now the from source heat is added Q1 and from sink then Q2 goes. So effective heat used in for this process to do what? Q1 minus Q2. Now after expansion some work, positive work is done, and in the compression negative work is done because work is done on the system. Okay, now this insulator, this head, cylinder head, sometimes in one process, for adiabatic process it acts as insulator. For the isothermal process it acts as a conductor. Okay, so this is the system. Let us go for the efficiency calculation. Okay, efficiency of Carnot cycle. I am doing mobile uploading, that's why you have to concentrate on my voice as well as when it is focused. When it is out of focus, please wait for some time, it will be on focus. In Carnot, efficiency Carnot, work done by the total work, net work done by the heat supplied to it. This is nothing but Q1 minus Q2. This is used for doing the effective work. Here W net I have shown you, this may be WE minus WP. This is Q1 minus Q2. This is the actually giant equation, efficiency equation. Heat rejection by heat addition minus, this minus comes from Q2 is resistance minus. So is equal to 1 minus, this is the for doing the isothermal work. This is the equation of the work done. Integration of PdV. If you do it, it will be like this: RT2 into ln V3 by V4, RT1 into ln V2 by V1. This is Q1, this is Q2 per kg mass of the fluid flowing of the system, in the system. Okay, now you see V3 by V4 and V2 by V1, these are have some relation. Of course, we will be proving. Now, applying adiabatic law to process 2, 3 and 4, 1. Okay. Okay. P2 V2 is equal to RT1. P3 V3 is equal to RT2. So Q1 by T2 will be equal to Q1 by T2 is equal to P3 by V2 to the power gamma minus 1. This is for the process 2-3. Here similarly for 4-1, the same equation left hand side, T1 by T2 will be equal to V4 by V1 to the power gamma minus 1. Okay, so from here you can easily understand that V3 by V2 will be equal to V4 by V1. Okay, so V2 by V1 will be equal to V3 by V4. Here V3 by V4 will be equal to V2 by V1. So this cancels out, RR cancels out. So we have N Carnot is equal to 1 minus T2 by T1. This is most important. Only thing is that we have to know the equation for heat addition and equation for heat rejection. Equation means this formula, this one. This has come from work done. This integration of P dV. Okay. Thank you. Now, what are the drawbacks? Now, drawback lies in the assumptions. Frictionless motion of the piston through cylinder is impossible. Frictionless is okay. This is the number one. An interchangeable cylinder head makes engine impractical. Sometimes the head will act as a conductor and sometimes it is insulated. Not possible. Isothermal expansion is a very slow process and adiabatic expansion should be very fast. This is impractical in a single stroke of the piston. This is not possible. So these are the drawbacks of the Carnot cycle.